Okay, ladies and gentlemen, this is going to be our last experiment, and it's going to last 3 weeks. And we have 4 more lab periods, so there's a week in there if you screw up one of the areas. Plus, I also have some ways we can get around it. But what we're going to be doing is experiment number 56, which is the multi-step synthesis of benzoic acid from benzaldehyde. And what I wanted to end the course with is what typically is true about manufacturing certain molecules is that it's not a one-step thing. And it turns out that in this lab, what we're going to do is 3 separate experiments. We will take on the benzaldehyde. We will turn that into a compound called benzoin the first week. And actually, that'll go into the second week. And then we'll take the benzyl, turn the benzoin into a compound called benzyl. And then we'll take the benzyl and we will turn into a carboxylic acid, the benzylic acid. So that's what's going to happen with this. We're going to do these 3 separate portions of the program. So the first reaction that we're going to be dealing with is the reaction of, it's a condensation reaction of 2 benzaldehyde molecules with one of the vitamins, thiamine, and we'll use the thiamine hydrochloride, a soluble form of vitamin B1. And what will happen is we will take that vitamin B1, and I want to just show you a different little website here. I have a full little 4-minute video you can go watch about the actual full mechanism. I'm just going to give you a quick underlying overview of what's going on. This is what the thiamine molecule looks like. And what's going to happen is you're going to treat it with sodium hydroxide, and you're going to create this. We're not going to worry about all of these parts of the molecule. We just want to focus on this part of the molecule here. And you'll see that what that's going to do is the OH is going to react with an H at this site where there's a double bond here. And it's going to leave those free electrons there from this as the H is taken away. And it's a condensation reaction where it makes water with that. We'll then take that, and I'm going to go over to this other one because I think it's really easy. We're going to call that thiamine with that extra electrons. We're just going to call it TH here. We'll take our first benzaldehyde molecule, and we're going to have a nucleophilic attack at that carbon, and the electrons will go up onto the O, and then we'll have this structure. And you'll see then that we'll have water, react it with water, and the water will put an H on the OH and regenerate our OH ion. Then we'll come in with the OH, come back in with base, pull off the H, and leave this as a carbon ion there at that point. And you'll see what we've done there at that point then is we've turned it essentially into this negative ion with that alcohol group, and the thiamine is still attached. Now we'll bring in, by the way, there was another condensation there where we took out another water. We'll bring in our second benzaldehyde molecule, you can see, and now because of those extra electrons there, we can have another attack by this negative ion to the carbon of the second benzaldehyde. And you'll see we'll create this massive structure now where we have, here's one of the benzaldehyde molecules here. There's our old friend from this half. And then you can see the new part here. We've kind of flipped this molecule over. And you can see that then we put those together at that point. Now we've created our bond between the 2 carbons, and we've lengthened this molecule. Now all we have to do is get one of these off there. So we're going to take those extra electrons there and bring in some more water and put the H on there and make the hydroxide ion again on that carbon. But please note, as we do that, we have added that to this one. We're going to come back to that original one that had the thiamine on it, treat it with a base again. And now what will happen is we'll get another condensation reaction, and the extra pair of electrons come in and create the benzoin molecule. And you can see that what benzoin is two benzene rings with an alcohol group and a ketone group in there in between it. So this is the benzoin. And I never did state that what our purpose is here is we're trying to see if we can use this thiamine hydrochloride, which obviously you can see here can be done, instead of the normal method of doing this reaction is using the deadly cyanide ion, which you would not have wanted to use in this experiment. So this is a much greener version using thiamine, vitamin B1, instead of using the deadly cyanide ion. You can go out and see this same condensation using cyanide, which was the original way that the reaction was done. Now, since this is going to be 3 weeks and 3 different things, that's all we're going to do for that part for this week. So what you're going to do, real simply, is, and this is very simple to do, but very long to do on this part. So I'll break the quizzes up into 3 parts, and we'll have quizzes over each part. So make sure you watch the video, because I'll have some questions about the mechanism. You can always go back and watch it as we're going along. So you're going to get 5 grams of the thiamine hydrochloride, that's the vitamin B1, and you're going to put that in 8 milliliters of water in a 125 milliliter Erlenmeyer flask. And then you'll add some ethanol. You're going to cool it in an ice water bath, and then you're going to be adding 10 milliliters of 3 molar sodium hydroxide drop by drop. And you're going to have a thermometer in there. The temperature cannot exceed 20 degrees Celsius at any point or time. Test the pH. If it's not above 9, add more NaOH. And now you're going to come in with your 150 millimoles. Make sure you do that calculation of pure benzaldehyde. It's going to be a brand new bottle. Then get some parafilm. After you've added the benzaldehyde, cover the mouth of it and put it in a hot water bath that can never exceed 65 degrees Celsius. That's going to be one of your taxing parts of it. You have to be between 55 and 65 degrees for, are you ready for this, a minimum of 90 minutes. That's going to be the difficult part. The rest of this doesn't take very long to do, but that part's going to be. And then that's not it. We're going to take that container and put it in the fume hood, and we're going to let that sit until next week. So, you know, it's going to be a long lab period, but you're not going to really be doing anything. So then what you'll do is you'll collect your material the following week, keep a little portion of it out, let it dry so you can get the melting point of that compound. I would just get a few pieces out and let them dry, and you can probably run that the second or the third week. And then you can go ahead with your material from part 1 and you can get into the second step. But I won't talk about that or the mechanism or anything of that until the following week. So this is really going to be a short video, and there's not much to it. You can see it's just really, 4 ingredients, and let it cook. The keys here are you cannot let it get above 20 degrees Celsius in the first part of the video, and you cannot let it get above, but it has to be between 55 and 65 degrees in the hot water bath. You have to try to regulate that temperature of that water between 55 and 65 for an hour and a half. So that's what it's going to be. When I send you the link on this, when you see this, you'll have the link to a short 4-minute video on a more detailed explanation of the mechanism. I'll give you the questions. The questions for this thing, there's only going to be one set of questions. We're only going to write one report, but it's going to count as 3. It will be a 150-point lab in that case. So it's going to be number 3 and number 4 only. We're not going to do very many because we're going to be pushed for time at the end. See you Thursday.